I use mine as a bookmark.
I use him to help teach my class.
It's time for game plans.
And for a limited time offer, you can get yourself a Silly Man too.
Let's move on to 8.52, the estimate of a population mean. All right, to estimate, the key concept here is estimating the population mean. And so if you think about the symbols we need to find the mean of the random sample, and this is going to be x bar. This one is mu, remember, because that's the population, and the one I just did is from a sample. Step 2, we need to determine the degree of certainty. So let's look in the chart. Number 3, find the error of estimate. What letter did we just find previously? That is our E. And then estimate the mean population, which is mu, by finding the interval. Okay. This is two problems here. And it's not an order pair, it's just a range, like interval notation. Okay? All right, let's go ahead and try this problem. Web traffic. A survey of 50 students at East High School asked how many websites they visit at least 3 times per day. The sample mean is 8.61 and the sample standard deviation is 2.6. Use a 95% confidence interval to estimate the mean for the population of East High School students. Okay, let's just get some information that we need. I have n equals 50 here. They visit them 3 times a day. Okay, not important. The sample mean, this is important. This is x bar equals 8.61. That's important. And the sample standard deviation, that is important. S equals 2.6. And then I have a 95% confidence interval. Okay, let's do a couple of things. The first thing I want to do is I want to calculate E. So let's see what we got so far. Do we have step 1? Yes. Now, degree of certainty. So a 95% confidence interval gives me a z-score of, look back at our chart, and our chart says 95% is 1.960. Okay, so we got that. Now I need to determine E. So E equals z times s over the square root of n. And remember we talked about just make that fraction bar really long. Okay, so let's just calculate E here. E equals our z-score goes right there, which was 1.960. And then our standard deviation, which was 2.6. And then we're going to get that by an n value of 50. Okay, so let's go ahead and put that into our calculators. Let's just not cheat, but just use our technology. Second enter. And I'm just going to go up here and change the confidence interval z-score, which was 1.960. And then over here, this one was 2.6. Close the parentheses and go downstairs, and then I think the score was 50. Okay, so I have an extra number. You just press delete, which is next to the left key. I can't undo. Okay, second enter. Sure, we could still do that. That's close to actually what we had, right? Delete that one, and this number was 2.6. And 1.9, great. Okay, awesome. 0.72. E equals 0.72. Okay, let's review what we've done. Step 1, we found X bar from the information above. Yes. Determine the degree of certainty. Yes. 95% gives me Z 1.960. We found E. Estimate the mean of the population by finding this interval. Okay, so hey guys. Magic. This is the formula that I need. Boom. Okay, so step 2, let's just find the interval. Okay, so X bar, here's a good thing. X bar is right there. It's the same number. We're gonna do it twice. .61. 8.61. Okay, then E, we just found E. Random colors here. Let's do purple. Do it again. Purple. 0.7. Well, that was dark. 0.72. E 0.72. E 0.72. So I'm going to subtract 1 and then add 1. And when you put that in your calculators, you're going to get 7.89 and 9.33. Okay, so that's kind of like our answer. Box it, and then I'm going to write the sentence to help you understand. What kind of confidence interval? At a 95%. Again, feel free to copy and paste this sentence frame. Now we're using this to estimate what the population mean. Is 7.89 from above. And population mean is this score. So now I'm just using an inequality here to represent my range. Therefore, we are how confident? 95% confident that the number of website users or students visit at least 3 times a day is between 7.89 and 9.33. All right, directions in questions 4, 5, and 6. Skip 1 problem below. Go ahead and try those on your own. We're basically using the same information we did in 8.51 to calculate E, and then now you're just using the interval. All right, let's try the freight problem. I have a sample package of 200 packages at a shipping company is weighed. The sample mean, so X bar equals 5.8 pounds, and the sample standard deviation S equals 2.7. Use a 90% confidence interval. So what's our E value? Well, I'm going to have to calculate the Z first. So a 90% confidence interval gives me a Z score of, look at your chart above, 1.645. E is equal to the Z times S all over the square root of N. So let's go and plug a chug away, substitute. All right, our Z score is 1.645. And then our S value is 2.7. See how that color coding helps? Helps you kind of visualize and see what's happening. 2.7 all over the square root of, we need an N value, which is 200. And this will give us a an E value. Okay, so second enter, we had a blah 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 90% confidence interval, and a 90% confidence interval will give me, I'm looking for my chart, blah blah blah, my chart at 90%, 1.645, and then our standard deviation was 2.7, and then our N value was 200. Go right key and then press enter, press it too many times, we got 0.31. Okay, then question number 2 says, what is our mean? And we get this, we can't confidently say what it is, so we can give a range, okay? So our range is x bar minus the E and x bar plus the E. And our x bar is 5.8. Don't need that one. That's a plus, plus, minus, and our E values from what we just found. Let's do a different color. Blah. Why is it so thick? Why does it do that? 0.31. 0.31. Okay, so 5.8 minus 0.31 will give me 5.49 and 6.11. So again, we don't know what the total, the population size of those packages are, but we are 90%. Let's write that sentence frame. Guys, this is what I'm telling you about. Technology is really helpful for me. Instead of writing all that out, let's see. Magic. Magic. Alright, let's do some erasing at a, what, 90% confidence interval. The population mean is, what was our answer? Five point 49 to 611. Therefore, with 90%, confident that the number of weight of packages the weight of packages is between 5.49 and 6.11. Pretty confident, right? We don't know the exact weight, but we can be pretty confident. All right, let's try airlines. A survey of 700 airline passengers. So let's use a different color. N equals 700. Asked about satisfaction. The passengers must rate the airline on a scale of 1 to 10. Okay, confusing. That doesn't matter. Where 1 is satisfied and 10 is extremely satisfied. 1 is not satisfied, 10 is extremely satisfied. The sample mean, so that would be our X bar, is 5.5. Standard deviation is 1.5 and a 99% confidence interval. So first thing I'm going to do is find E, but to find E, I need to find my 99% confidence interval gives me a z-score. Just look back at my chart up here. Candy, Reese's Pieces. 2.576. 2.576. And then to find the E value, it just means E equals Z times S over N. Okay, our Z score, we just found that, goes here. Our standard deviation, 0.5. And our N value is 700. Second enter. Is that nice? 2.576. Let me double check. Even I have to reference them. I have not memorized them. Yes, that was correct. And then our standard deviation was blah, 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 1.5. And we had 700. Oof. 0.15. 0.15. Okay, so now we're going to figure out what the population mean is with our confidence interval. To do that, I'm going to have what we call the, what do we call this? Estimating a population mean, which is X bar minus E and X bar plus E. Okay, where do I get X bar? This number comes from reading right there, 5.5. E is 0.15. Let's write that a little bit nicer, Mr. Ing. And then when you do that, our two numbers are going to be 5.35 and 5.65. And check this out. If I, let's see, still saved. It's okay. Come back here. Do it again. Do it again. Okay, at least we have a starting point. At a 99%. Confidence interval, the population mean is between 5.35 and 5.65. Therefore, we are 99% confident that the, what are we talking about in this problem? That the rating of the airline is between 5.35 and 5.65. Okay? All right. Before I lose it, let's try to paste that over here. What color do we like? Blue? Alright, let's do all blue. And let's just do the problem. Alright. I just want to use that for later. Okay, question number 6. Credit hours. Sample of 650, n equals 650. College students are surveyed about the number of credit hours they are taking this semester. Credit hours is basically kind of like in high school, you guys get 5 credits per semester. And in college or semester-long classes, you get 3 credits hours for a semester. It says the sample, so x bar equals 14.75, and the sample standard deviation is 2.25. 95% confidence interval, so let's go ahead and do our work here. So a 95% confidence interval gives me a z-score of 1.960. And then E equals Z times S over square root of N. Okay, so the Z is 1.960. What is our standard deviation? 2.25. And then a square root of n, which is a lot of people, 650. Alright, so if I take pictures, I don't forget the numbers, boom, come over here, let's do it all at the same time again. 1.960, 2.25. Okay, I'm going to close my parentheses to show that this is the numerator divided by square root, second x squared. 650, it says red there, so push right. Close the parentheses and then press enter. 0.17. 0.17. And then I need to calculate a range in which the population mean would be. So x bar minus E, x bar plus E. And our x bar is 1475. So 1475. Our E value .17. So if I put in my calculator 14.75 minus 0.17, I will get 14.58 to 14.92. Okay, so that means at a 95% interval, erase all the things I'm not going to need in here. At a 95% confidence interval, the population mean is 14.58 to 14.92. Therefore, we are 95% confident that the number of credits hours taken by college students is between 14.58 and 14.92. Okay, so that was 8.52.
I think most of us can definitely agree math rocks. I can prove so. Right here, as we can see from this image, they're totally high-fiving because math rocks. And it actually appears like they're stating a couple of the math commandments. I think that says, "Thou shalt not write thy math papers in ink. Thou shalt show all thy work." I mean, as we can see right here, they're totally saying that. But in conclusion, math rocks. I love math.